Good evening, Lamai. Good evening, Putala. Right. Good morning. Sorry. Good evening. Good morning. Good evening. මේ අපේ classes වල පුතේ දැන් unit 3 අද English medium unit 3 day 2 day 1 අපි last week කරා just introduction that I explained only meaning of oxidation, right? The chemical calculation lesson based on calculation part including redox and nomenclature. So the last week, exactly last Wednesday, we discussed what is mean by oxidation, reduction, oxidizing agent, reducing agents, as I remember, yeah. And then examples for the redox reactions and simple redox reactions and simple oxidation reaction. Additional to that, how we get the oxidation number of the central atom when we have a molecule by taking the formula method and structure method, right? So you can go through your note. Those are the points that we discussed last day, right? Then we will continue with the last part. And today I'm going to explain you how to balance chemical reaction using the redox technique, redox method before the nomenclature part, right? Before the nomenclature part. So before that, I want to explain you what is meant by oxidizing agent, what is meant by reducing agent. So we'll continue. I'll take the really easy two equations. The first one I'll take conversion of the sodium into solid state, so gaseous state, into sodium plus gas. So this reaction is oxidation, reaction related with the oxidation. How we define that? When we take the reactants and the products, you can see there's electrons in the product side. Simple meaning, removing electrons called oxidation. Removing electron called oxidation. And the other way, increase in positivity, also oxidation. Removing electron is oxidation. Removing electron, you can write down. Removing electron is the oxidation and increase the positivity of its oxidation number, also oxidation. So here the charge is 0. Here charge is +1. That part we have explained. I have explained the last week. So increase the positivity. 0 and +1. +1 is more positive than the 0. So increase positivity, that is oxidation. That is oxidation. So meaning of the oxidation, removing electrons. Removing electrons. Or you can write increase positivity. Increase positivity. Removing electron called oxidation, or increase positivity we call oxidation. Oxidation. Cl minus, Cl gas, fluorine atom, take 1 electron. After gaining electron, it goes to Cl minus. Cl minus. Cl minus. So this called reduction. Reduction. Why we call reduction? Gaining electrons. Gaining electrons. Gaining electrons. And secondly, initial oxidation state of chlorine is 0. After gaining 1 electron, it becomes -1. So that is increased negativity. Increased negativity called reduction. Gain in electrons called reduction. Increased negativity called reduction. In other way, reducing positivity. Right? Decreasing positivity. Decreasing positivity called reduction. For oxidation, you can write reducing or a decreasing negativity. Decreasing negativity called oxidation. So this is the oxidation, this is the reduction. When the sodium release electrons, the release electrons can be taken by chlorine atom. Again, when sodium release electron, the release electrons can be taken by chlorine atom. Removing electron, that is oxidation. When sodium undergoes to oxidation, in other way, it helps to reduce to the chlorine. When sodium release electrons, it helps to take the electrons by chlorine. So removing electrons, oxidation. Gaining electrons, reduction. Gaining electron, reduction. So when sodium goes to oxidation, it helps to reduce to the chlorine atom. Therefore, when we give another name for the oxidized element or a component as reducing agent. Reducing agent is the supporter which helps to reduce. So sodium oxidized release electrons taken by chlorine atoms when it goes to reduction. So sodium or an oxidation component known as reducing agent. Reducing agent. So remember that this is reducing agent. Reducing agent. Right? Intermediate one which helps to reduce. When chlorine takes electron from sodium, when chlorine takes electron from the sodium, it helps to remove the electron from the sodium. When chlorine takes the electron, it helps to remove the electron from the sodium. So when chlorine reduces, it helps to oxidize reaction here. Therefore, reducing, right, reduced component we call oxidizing agent. Reducing component we call oxidizing agent. So this is the oxidizing agent. Oxidizing agent. Reducing agent, oxidizing agent. Oxidizing action is the action because of the oxidation process. Reduction action means the action because of the reduction process. Reduction same as reduction action. Reduction ability. Right? Oxidation same as oxidizing ability, oxidizing action. But oxidation we define with the different name, that is reducing agent. Reduction name differently as oxidizing agent. Clear, Putala? So that is another theory part you should remember when you're doing the calculations related with the redox. I'll give 2 minutes. Please note down, hurry up, guys. Right. Then, shall we check how the hydrocarbons change their oxidation number during the oxidation and reduction reaction. Oxidation and reduction, the total we call redox. Reduction, RED, oxidation, OX, right? Reductions and oxidations are two reactions, but simultaneously take place. Right, here, for example, I take combustion of CH4. CH4 is hydrocarbons containing carbon and hydrogen only. So CH4 gas react with O2 gas as a main products, carbon dioxide gas and water liquid form at STP. STP means standard temperature and pressure, the room temperature conditions. So water as a liquid form. When you take this reaction, one carbon, therefore one carbon dioxide, 4 hydrogens, therefore you need to multiply water by 2. 2 into 2, 4 hydrogen can balance. 1 carbon, carbon also balance. There are 2 plus 2, totally 4 oxygens. To balance the oxygen in the reactant side, you need to multiply this by 2. Like here, CH4. As I explained last week, electronegativity of hydrogen is +1, electronegativity of hydrogen is 2.1, carbon is 2.5. So carbon has greater electronegativity than hydrogen. Because of that, for a one bond, highest electronegative one take -1, lower electronegative ones take +1. Here, due to this one, +1 -1, due to this one, +1 -1, due to this one, +1 -1, due to this one, +1 -1. So the oxidation number is the overall charge because of the 4 bonds formed with the hydrogen. So that is -4. The carbon in CH4 has -4. 1 hydrogen has +1. There are 4 hydrogens. Therefore, +4. +4 -4. When you take oxygen, oxygen is non-polar molecule, homoatomic molecule. So one oxygen takes 0 oxidation state, 0. Then you take carbon dioxide. This is the carbon dioxide, CO. Here -2 + 2. Carbon is 2.5. Oxygen is 3.5. Hydrogen is 2.1. Because of the double bond, oxygen takes -2, carbon takes +2. Because of this double bond, +2, -2. So overall charge here is +4. 1 oxygen takes -2. There are 2 oxygens, therefore -4. When you take water, here hydrogen takes +1, oxygen takes -1, hydrogen takes +1, here -1. Now you can see oxygen takes -2. There are 2 water molecules, therefore -2 into 2, -4. 1 oxygen takes +1. There are 2 hydrogens for 1 water molecule. Totally 2 water molecules in the balanced reaction. Therefore, you need to multiply +1 by 4. Therefore, here plus. Now you can see initial oxidation states and final oxidation state of the compounds given here. Initially, oxidation state of the carbon is -4. Oxidation state of the carbon is -4. But when it turns to carbon dioxide, -4 change to +4. -4 change to +4. Increase positivity called what, guys? Increase positivity called oxidation. Oxidation. Minus here, number line 0, -4, +4. Initial oxidation state of the carbon is -4. When it forms carbon dioxide, oxidation state change to +4. So total number of electron transfer the other way, the total number of electrons remove. Here, -4 to 0, 4 electrons. Another 4 electrons removed by carbon when it forms +4. Totally 8 electrons removed by carbon. Then methane, CH4 goes to CO2. Here, hydrogen +1 into 4, +1 into 4, not change, then hydrogen H plus in methane goes to H pluses in water. So hydrogen H pluses in methane and water, the remaining constant, it doesn't change. Then look at the oxygen. Here, the initial oxidation state of oxygen is 0. The 0 oxidation state changed to -4. Increase in negativity called reduction. Reduction. When 0 goes to -4, it takes 4 electrons. 4 electrons. When oxygen form water, again 0 changed to -4. Another 4 electrons taken by oxygen, it's also reduction. Here, 4. So totally 8 electrons taken by oxygen when it forms carbon dioxide and water. When carbon goes to carbon dioxide, initial oxidation state -4 goes to +4. The total number of electron transfer, that is oxidation, totally 8 electrons. Those removed electrons taken by oxygen then form carbon dioxide and the water. So this is the redox reaction. Combustion of hydrocarbon. Combustion of hydrocarbon is redox reaction. One is removing electron, the other one is taking electron. The oxidation and reduction reaction take place simultaneously. එක්කෙනෙකුට බලාගෙන ඉන්න බෑ අනිත් එක්කෙනා දෙන්න. මම කාට හරි මේ පෑන දෙනවා කියලා කිව්වොත් දුන්නා වෙන්නේ එයා මේ පෑන ගත්තොත්. එයා පෑන ගත්තේ නැත්නම් ඒක දුන්නා වෙන්නේ නැහැ. Right? So this is the examples for combustion of hydrocarbons. Remember that combustion of hydrocarbons is also redox reaction. Right? The transferring electrons. Carbon in methane goes to oxidation. Oxygen in O2 goes to reduction. Right, note down. Oh yeah, the another computer simple meaning sorry, Lian. So this classic in details theory cover karne kak neveyi. Right? Tak gal theory ticket ma cover karna මොකද ගොඩක් දරුවෝ ඇත්තටම සතුටුයි. Right? ගොඩක් දරුවෝ ලංකාව පුරාම සෑහෙන පිරිසක් මේ වෙනකොට online physical classes වලට join වෙනවා. ඉතින් ගම් පහවට ළමයි කඩවත ක්ලාස් එකට එන්න science image අලුතෙන්ම පටන් ගත්තේ පුතේ February මේ month එකේ February month එකේ අපි first week start කරේ class එක right science image class එක ඉතින් ගම් පහ ළමයි right කිරිදිවෙල ප්‍රමේත් මේ දැනුත් කතා කරා දරුවෙක් කිරිදිවෙල ඒ පැත්තෙන් ඉඳන් දරුවෝ බය නැති වෙන්න class එකට පුතේ විශ්වාසයෙන් එන්න අනිවාර්යයෙන්ම ගොඩ දානවාමයි. Right, මේ දවස්වල මගේ Facebook බලන්න, TikTok, Insta, YouTube ඔක්කොම බලන්න. Right, ඒ හැම එකම තියෙනවා. ඔයාලා වගේම මගේ classes වල ඉගෙන ගන්න දුවල පුතාලගේ ඇත්තටම හදවතින් right ඒගොල්ලෝ අවංකවම කියන අදහස්. ඒක තමයි මගේ තියෙන පත්කම. right මට මේ මාස 8ක් පුරාවටම 26 දරුවන්ට ලොකු දෙයක් මම කරලා තියෙනවා. 25 ගැන නම් කතා කරලා වැඩක් නැහැ. කරන්න පුළුවන් උපරිම කරලා තියෙන්නේ right ඒගොල්ලෝම මම මේ දවස්වල වෙලිසවන්නේ නැහැ. මොකද ඒ ළමයින්ට තියෙන rush schedule එකත් එක්ක ඒගොල්ලන්ට විනාඩි 5ක් 10ක් කෝටියක් වටිනවා. මම ඒ දරුවන්ට කරදර කරන්නේ නැත්තේ ඒකයි. අපි 21 22 23 රිසර්ච් වලින් පෙන්නලා තියෙනවා. අපි කොච්චර ස්මාර්ට් ක්ලාස් එකක්ද කොච්චර වැඩ කරන ක්ලාස් එකක්ද right ඒ වැඩ ප්‍රමාණය දරා ගන්න බැරි මිනිස්සු මගේ Facebook ඔක්කොම right report ගහලා ඒ ඔක්කොම නැතිලා දැන් ආයෙ අලුතින් ඒවා පටන් අරගෙන ඉඳලා වාසනාවකට ඒ මිනිස්සුන්ට හරි රුදාවලම ඇත්තටම කිව්වා අලුත් account එකටත් හෙන්නට report වදිනවා right ඒක නිසා කරන්න දෙයක් නැහැ රිදෙන තරමට ඒගොල්ලන්ට රිදෙන තරමට මම තව ඉස්සරහට යන එක තමයි වෙන්නේ ඉතින් මේ process එක ළමයින්ට උගන්වන එක ළමයි වෙනුවෙන් කැප වෙන එක ස්ටොප් කරන්නේ නැහැ කවුරු කොහොම කරත් රයිට් ඉතින් ඒක නිසා දූල පුතාලා එන්න කඩවත ක්ලාස් එකට එන්න සයන්ස් ඉමේජ් රයිට් ඔයාලට හොඳ එන්වයරන්මන්ට් එකක් තියෙන තැනක් සෑහෙන වැඩ කොටසක් කරවන තැනක් බය වෙන්න එපා කියන ලොකු විශ්වාසයක් නුගේගොඩ සැසිප් ආයතනයේ උගන්වන හා සමානම රයිට් පොඩ්ඩක්වත් අඩුවක් කරන්න තු එතන කරනවා ඒ වගේම රත්මලානි ක්ලාස් එක මගේ ගෙදර ක්ලාස් එක රයිට් විදුර අපි මම වෙනස් තැනක කරේ නමුත් මම දැන් ඒක මගේ ගෙදර ක්ලාස් එකට ගෙදරට ගෙනලා තියෙන්නේ රත්මලානි අපට මොරටුව රත්මලාන ගල්කිස්සාවට ඉන්න දරුවෝ රත්මලානි ගෙදර ක්ලාස් එකට එන්නේ 2026 27 25 නම් මම දැන් තීරි ක්ලාසස් වලට ළමයිව ගන්නෙ නැහැ හේතුව අපි දැන් තීරි ඉවර නිසා අපිට තව එක පාඩමයි තියෙන්නේ ඉතින් තීරි ක්ලාසස් වලට සම්බන්ධ මේකේ තේරුමක් නැහැ හැබැයි 25 ඒරල් කරන දූල පුතාලට අපේ පේපර් ක්ලාසස් වලට සම්බන්ධ වෙන්න පුළුවන් එහෙමත් නැත්නම් රිවිෂන් ක්ලාසස් වලට සම්බන්ධ වෙන්න පුළුවන් මාස 6කට ඉස්සෙල්ලා පුතේ සම්පූර්ණම සිලබස් එක අකුරක් නෑර රයිට් ඉවර කරනවා. අපි ක්ලාස් පටන් ගන්න පළවෙනි දවසේම ළමයින්ට දෙනවා අපේ ප්‍රෝග්‍රෑම් එක අපි මෙහෙමයි වැඩ කරන්නේ. මෙන්න අපේ ප්‍රෝග්‍රෑම් එකේ මාසෙට අපි කරන වැඩ කොටස මේ වෙනකොට ඒවා ඉතාමත්ම සාර්ථක ලෙස යනවා. රයිට් කිසිදු අර ළමයින්ට කරදරයක් පීඩාවක් නැතුව මගේ පන්ති වලට එන ළමයි හරිම සතුටින් පන්ති ඉන්නේ. එහෙම ලේසියෙන් ළමයි ක්ලාස් එකක් කට් කරන්නේ නැහැ. රයිට් ඒක නිසා අලුතෙන් දුවල පුතාලා බය වෙන්න එපා. ඔයගොල්ලෝ මාස 8ක් වැඩ කෙරුන්නේ නැහැ කියලා ඒ ගැන දුක් වෙන්න එපා. අපේ ගිය අවුරුද්දේ 23 සඳනිකායියා කෙමිස්ට්‍රි වලට ඒකක් ගත්තේ. රයිට් ඒ දරුවාගේ අවසරය ඇතුවයි මම මේ කියන්නේ. රයිට් ඒ දරුවාගේ මම ෆොටෝ එකකුත් දාලා තියෙන මගේ ලීෆ්ලට්ස් වලට සඳනික දයාරත්න ඒ පුතාගේ සම්පූර්ණ අනුමැතිය අරගෙන යාගෙන ෆොටෝ එක ගෙන්න ගත්තේ. ඇත්තට තමයි මම යාගේ මගේ ලීෆ්ලට්ස් වලට මම දාලා තියෙන්නේ. ඒ පුතා මංගාවට ආවේ මාස 10යි. මාස 10න් කොල්ල සුපිරි එකක් ගත්තා. අවාසනාවට අනිත් සබ්ජෙක්ට් එක ඩවුන්. හැබැයි බය නැහැ. පුතා මේ පාර කරා කොල්ල අනිවාර්යයෙන්ම සුපිරි තුනක් දාලා තියෙන්නේ. ඒ බය ඒ විශ්වාසෙත් එක තමයි යාගේ ඩීටේල්ස් ඇඩ් කරලා තියෙන දේ නිසා අපිට බයක් නැහැ. 23 කොල්ල ඒ තුනක් දාලා තියෙන 24 එක්සෑම් එකේ. අපි ඒක බලමු 24 රිසර්ච් අවුට් වෙනවා. මම හිතන්නේ ඒප්‍රිල් ෆස්ට් වීක් වෙනකොට රිසර්ච් අවුට් වෙයි. අපි බලමු ඒකේ විප්ලවය රිසර්ච් අවුට් පස්සේ බලමු. ඉතින් බය වෙන්න එපා නුගේගොඩ ඒ යවටින ළමයි නුගේගොඩ සැසිප් පාර්තනයත් එක්ක සම්බන්ධ වෙන කඩවත ක්ලාස් එකත් එක්ක සම්බන්ධ වෙන යට දරුවෝ ටික රයිට් රෑ වෙනවා ওই වගේ ප්‍රශ්න සුළු කාලයයි පුතේ හොඳේ රෑ වෙනවා ට්‍රාන්ස්පෝර්ට් ඉෂුව යන්න බැරි වෙනවා ටීචර් එක දවසකට තාත්තට හරි අම්මට හරි පොඩ්ඩක් රෑට එන්න කියන්නේ මොකද ડોක්ටර් කෙනෙක් නැත්නම් ඉංජිනේර කෙනෙක් වෙන්නනේ යන්නේ සෙල්ලම් නෑනේ නේ රයිට් නදීෂ ටීචර්ගේ ක්ලාස් එක කට් කරන්න එපා පුතේ ඒක මාර පාඩුවක් ඔයාලට රයිට් ඒක තේරෙනවා ඔයාලට මගේ ක්ලාසස් වල මුල ඉඳන් ආපු දරුවෝ කියන දේවල් මේ දවස් තව වීඩියෝ එකටම එනවා රයිට් ඒවා කියන දේවල් ඇහුවා නම් ඔයාලට තේරෙන්නේ මේක කොච්චර වෙනස් ක්ලාස් එකක්ද කියලා ඉතින් ඒක නිසා රැය විලාව බලන්න නැතුව එන්න සෙට් වෙන්න වැඩ කරන්න මහන්සියමු ડોක්ටර් කෙනෙක් ඉංජිනේර කෙනෙක් වෙමු ෆස්ට් ටයිම් අපේ ටාගට් එක අපි හරියට කරමු රත්මලානියට ළමයි දරුවන්ට රත්මලානිට ඒ තුනෙන් එකකටවත් එන්න බැයි නම් ඔන්ලයින් විවෘතයි ඔයාට ඔන්ලයින් ක්ලාසස් වලට සම්බන්ධ වෙන්න රයිට් ෆිසිකල් ක්ලාස් එකක් වගේම තමයි කතා බහ කරලා හොඳට වැඩේ කොට දාලා දෙනවා ඔයාලගේ පේපර්ස් එකක් බලලා PDF එකක් ගන්නවා ඔයාලා ක්ලාස් එක ඇතුලේ හදන ගණන් වල අපි ෆොටෝස් බලනවා රයිට් වැඩ ගොඩක් තියෙනවා සහ මතක තියාගන්න මේක හැමදාම රොටේට් වෙන process එකක් නෙවෙයි අපි අප්ඩේට් වෙන ක්ලාස් එකක් මේ මාසේ තියෙන plan එක නෙවෙයි අපේ ලබන මාසේ ඒවා රහසක් රයිට් මේක දාගන්න අපි ටික කන්ටිනියු කරමු right මගේ පැටව මේක ලියලා ඉවරයි නම් අපි second example එක විදියට දෙන්නම් පුතේ විනාඩි දෙක තුනක් අතර try එකක් දෙන්නකෝ මම ඒක explain කරන්න right then the second one combustion of I give this one CH3 CH2 CH3 CH3 means one carbon connected with three hydrogen atom and this carbon connected with the second carbon and this one connected with this carbon, right? Like the linear chain. So this is the structure. Same products will form as carbon dioxide and water. And please continue, right? I'll explain each. I'll give 2 minutes. Please do fast. Right, finish. Shall we check the answer? Right, CH3, CH2, CH3. Here carbon, 3 hydrogen atoms. Second carbon, 2 hydrogen. Third carbon, 3 hydrogen atoms. Why we have to put the hydrogen atoms like this? Because the carbon is the 14th group element. The valence is 4. Therefore, around the carbon, there should be 4 bonds. Right? 4 bonds. So each carbon should be connected with 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The valence of the carbon is 4. React with oxygen. Mainly produce carbon dioxide plus water. Water at room temperature, water in liquid state. So here, carbon. First we need to balance 1, 2, 3 carbons. Therefore, multiply carbon dioxide by 3. Here, carbon oxygen. Water, H2O like this. And hydrogen 1, 2, 3, 4, 5, 6, 7, 8. Therefore, you need to multiply water by 4 to obtain the same number of hydrogen in the product side. So we have 4 H2O. Total oxygen in the product side, 3 into 2, 6, plus 4 is 10. 10. Therefore, you need to multiply O2 by 5 to obtain the 10. Clear, Papala? Then mark their charges. Here, plus 1 minus 1, 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 plus 1 minus 1. Because of the same atoms, 0 charge. Because of the same atoms, 0 charge. So overall charge here is minus 3. Overall charge here is minus 2. Overall charge here is minus 3. So this carbon takes minus 3, this carbon takes minus 2, this carbon takes minus 3. The overall charge or the oxidation state of all carbon here is minus 3, minus 6, minus. 1 hydrogen takes plus 1. There are 8 hydrogen, so plus 8. Minus 8 plus 8. 1 oxygen takes 0 charge. Here, minus 2 plus 2 because of the double bond. Minus 2 plus 2 again because of the double bond. So now you can see 1 carbon takes plus 4. There are 3 carbon dioxide. Therefore, you need to multiply this by 3. So totally plus 2. 1 oxygen takes minus 2. Minus 2. Total oxygens are minus 6. Therefore, total oxidation state is minus 2. 1 hydrogen plus 1 minus 1 plus 1 minus 1. 1 hydrogen plus 1. There are 2 hydrogen for 1 water molecule. Totally 8 because of the 4 H2O. So here plus 1 oxygen minus 2. There are 4 water molecules. Each water has 1 oxygen. Therefore, multiply this by 4 minus. Now you can take simply. Here, minus 8 goes to plus 12. Minus 8 goes to plus 12. So, increase positivity. Increase positivity. Increase positivity we call oxidation. Oxidation. Starting from minus 8, 0, then plus 12. Minus 8 to 0 is 8. 0 to 12 is 12. So totally 20 electrons get removed by carbon when it forms carbon dioxide. Hydrogen plus 1, here plus 1, hydrogen remain constant. Here oxygen, when oxygen goes to carbon dioxide, increase negativity, so that is reduction. When oxygen form carbon dioxide, totally 12 electrons taken from this 20, 12 electrons taken. When this oxygen goes to water, totally 8 electrons taken. So total electrons is 12. The total number of electrons removed by carbon is 12. The total number of electrons taken by oxygen when it forms carbon dioxide and water are 20. So carbon oxidize, oxygen reduces. So this one also a redox reaction. No doubt. Right, done. Okay. Right, then we'll do redox balancing in acidic and basic media. Redox balancing in acidic and basic media. Now the topic, balancing redox reaction. Balancing redox reaction in acidic and basic media. Balancing redox reaction in acidic and basic media. First, under subtitle, write the subtopic. Balancing redox reaction in acidic media. Balancing redox reaction in acidic media. Right, Putala, before that we have to take some summary. Right, before the reaction and after the reaction. Not down. Before reaction. After the reaction. Before reaction and after the reaction. MnO4 minus. Remember that the color is purple. Called permanganate. Permanganate. I didn't do the nomenclature part now. So to get the calculation part, first we need to do this part. So after doing the redox balancing, I'll cover the nomenclature part. Right, MnO4 minus we call purple. In acidic medium, MnO4 minus permanganate ion change to Mn2 plus. The color is pale pink. Pale pink. Then we have C2O4 2 minus. We call oxalate ion. This one is permanganate. Permanganate ion. This one is oxalate ion. Oxalate ion. C2O4 2 minus change to CO2. CO2. Cr2O7 2 minus we call dichromate ion. Dichromate ion. Initial color is orange. It changed to Cr3 plus. Cr3 plus, that is green. CrO4 2 minus called chromate ion. Chromate ion. Color is yellow. Change to Cr3 plus, again green. Fe2 plus oxidized to Fe3 plus. Fe3 plus. If you take NO2 minus, NO2 minus, it changed to NO3 minus. If you take sulfide, it changed to sulfur. Sulfur yellow precipitate. Yellow precipitate. And when you take sulfide, it changed to sulfate. When you take copper, it goes to copper 2 plus. When you take copper, right, copper plus, like copper 1 iodide form, I will say that. Copper, what else we, sulfide, sulfate, sulfide, sulfur, NO2 minus, NO3 minus, copper, copper 2 plus. Fe, if we have Fe, it goes to Fe2 plus. When we have copper with potassium iodide, it forms copper 1 iodide, right? That's also white precipitate. White precipitate. Copper and potassium iodide, it forms copper 1 iodide. White precipitate. And S2O3 minus, we call thiosulfate. Thiosulfate ion changed to S4O62 minus, we call tetrathionate. Tetrathionate ion. Right? Then we have I2. It goes to I minus. I minus. I2 goes to I minus. ඇති නේද? Right. ඔය චුට්ට ලියාගමු පුතේ. අපි බලමු. ලස්සනට ලියාගමු. Right. Done. වැඩ කරන්න ඕනේ පුතේ. කන්න බෑ. Right. And මම මේක erase කරනවා. Right. Now I'll explain how to balance reactions, redox reactions. Redox reactions. First one, I'll take reaction in between MnO4 minus and Fe. MnO4 minus and Fe in acidic medium. Acidic medium. Now you know what happened to Fe in acidic medium. In acidic medium, Fe, look at the chart, Fe turns to Fe2 plus. First you should write correct reaction, means correct reactants and products. First write down correct reactants and products. Here, Fe, the physical state is solid, iron is solid. Change to Fe2 plus. All cations and anions. All cations and anions existing in aqueous medium. AQ. Aqueous medium. Right? Except mercury and Br2. Mercury and Br2 liquid form. Other all elements. Other all elements, metals in solid. Mercury, except mercury, other metal exist in solid state. So if Fe is solid, Fe2 plus is iron, therefore physical state is aqueous. First we need to write correct reactants and products. After writing reactants and products, we need to balance oxygen. To balance the oxygen, we need to add water. The first point is correct, write down correct reactants and products. Reactants and products. Second one, balance oxygen, adding water. Adding water. Third one, balance hydrogen, adding H plus, because the reaction takes place in acidic medium. To define the medium as acid, we can add H pluses. First, we need to balance. First, we need to write the correct reaction, including correct reactants and products. Second one, balance oxygen adding water. Balance hydrogen adding by adding H pluses. Before that, you need to balance the main element. Okay, right? Here, Fe. This side should also have one Fe. Right? If I change that, balance oxidized or reduced element. 3, 4. Finally, balance charges. Adding electrons to the most positive side. Most positive side. Let's look at the board. Here 1 Fe, here 1 Fe. So both sides having same number of Fe. We don't have oxygen and hydrogen in this reaction. Therefore, we no need to add H2O and H pluses. So we skip second, third, and fourth. Then step to balancing charges. This side has zero charge. We explained that last week. Zero charge. This side has +2 charge, +2 charge. So we have permission only to add in electrons. Electrons are negatively charged particles. Always we add electron to the most positive sign. Here 0, here +2. So most positive side is this one. We need to add electrons to get the same charges in the reactants at the product side. So here 0, here +2. Therefore, we need to turn the total charges in the product side as a 0. Therefore, we should add 2 electrons. Here 0 charge, +2 minus 2 electrons are minus, +2 minus 2 also 0. So now you have the balanced oxidation reaction because removing electrons we call oxidation. Right? Then look at the next one, MnO4 minus. MnO4 minus goes to Mn2 plus. Look at the chart. MnO4 minus, that is iron. Therefore, physical state is aqueous. Goes to Mn2 plus. This is charge. Therefore, aqueous. Now, what is the first point? Balance oxidize or reduce element. Here 1 manganese, here 1 manganese. Therefore, both sides having same number of manganese elements. Then balance oxygen by adding water. Here, this side has 4 oxygen atoms. Here, 4 oxygen atoms. Here, no oxygen. Therefore, we need to add water to the side which has less number of oxygen. Here 4 oxygen, here 0 oxygen. Therefore, to get the same number of oxygen as reactant side, we need to add 4 water molecules. Add 4 H2O. Add 4 H2O. So after adding 4 H2O, now this side has 4 oxygen. This side also have 4 oxygen. But we have excessively added hydrogen. How many hydrogen? 4 into 2, 8. 4 into 2, 8. This side has no hydrogen. Therefore, we need to add hydrogen to the side which has less number of H pluses to get the same number of H pluses in the side. Here, 4 into 2, 8. 4 into 2, 8. Therefore, you need to add 8 H pluses to the reactant side. Because of the plus, the physical state is aqueous. Aqueous. So, number of hydrogen, number of oxygen, number of manganese, all are same. Finally, balance what? Charge. Here, there are H pluses. 1 hydrogen plus 1. Because of the A, here we have plus A. The overall charge here is -1. Here charge is -1. Plus 8 minus 1 is +7. So this side has +7 charge. Manganese +2 charge. Water 0 charge. Here +2. We need to add electrons to the most positive side. +2 and +7. Most electropositive one +7. So we need to reduce +7 to +2. +7 to +2. To reduce +7 to +2, We need to add 5 electrons. So add 5 electrons. Add 5 electrons. When the reaction is having electrons in reactant side or product sides, the such reactions we call half reactions. So this is the oxidation half reaction. Oxidation half reaction. Why we call oxidation? Because Fe goes to Fe2 plus, increase positivity or removing electrons. Because of the electrons in the product side, that is half. This one is reduction reaction. Reduction half reaction. Why we call this one as reduction? Because electron gaining. Electron gaining. Half reaction because of the electrons in the reactant side. So these two cause reduction and oxidation half reactions. Right, please send a message with the right. I should know whether you could understand what I'm explaining here. Right, hurry up, guys. Note down. Right. I'll give the second example. Please try to take the oxidation and reduction reaction. I'll give copper and oxalate. Sorry. MnO4 minus and oxalate in acidic media. In acidic media. Hurry up, guys. Take the answer for the second one. Right, finish, Putala. Right. Before moving to the second example, I'll tell you how to get the ionic reaction. These two are half reactions. How we get the ionic reaction? The way of getting ionic reaction is we need to get the same number of electrons and combine oxidation and reduction reaction together. After balancing the electrons, right? After balancing the electron, combine oxidation and reduction reaction, combine oxidation and reduction reaction to get the one reaction. Here, to balance the electrons, in the redox reaction, we have 2 electrons. In the oxidation reaction, in the reduction reactions, we have 5 electrons. To get the same number of electrons, you need to multiply this by 5, this by 2. When we multiply this one by 5, 5 times 2, 10 electrons. Here, 2 times 5, 10 electrons. 5 times 2, 10 electrons. 2 times 5, 10 electrons. Now number of electrons are same. Therefore, add these two reactions. In the oxidation reaction, we have only 5 Fe plus in the reduction reaction, we have 2 times MnO4 minus 2 MnO4 minus plus 2 times 8, 16 H pluses. We no need to write same component in both sides. That's why we no need to write electrons, because this 10 electrons get cancelled with this 10 electrons. And the product side, 5Fe2 plus 5Fe2 plus 2 times Mn2 plus is 2 Mn2 plus 2 times 4 is 8 H2O liquid. 8 H2O liquid. So how you check whether this reaction is balanced? Balance the charges. Check the charges. Here, minus 2 plus 16 is totally plus 14. Plus 14. Other side, 5 times 2 plus 10. Plus 10 plus 4 plus 14. So if the both sides having same number of charges, so such reaction is balanced reaction. I'm not going to explain how to get the chemical reaction now. We will explain, right? I'll explain later, because after you get in some maturity with the balanced redox reactions, it's easy to understand. Right, note down these one also, and I'll explain the second one. Right, then take the second one. Refer the chart, what happened to MnO4 minus and what happened to oxalate ion. MnO4 minus, now you know with the practice. MnO4 minus aqueous goes to Mn2 plus, because of the plus 2 aqueous. 1 manganese, 1 manganese. To balance the oxygen, you need to add water to the product side, 4H2O liquid. When we add in 4H2O, 4 into 2, 8 H pluses. We have added 8 H pluses, so here 8 H pluses. To balance the charges, now you know we need to add 5 electrons to the products reactant side. Then C2O4 2 minus. What happened to C2O4 2 minus? It formed CO2. CO2 is gas, carbon dioxide. Here 2 carbon. Therefore, to get the same number of carbon here, multiply this by 2. Then 2 carbon, 2 carbon. 4 oxygen, 2 into 2, 4. Overall charge here is -2, here 0. To get the same charges, we have permission to add electrons only. How much of the electrons should be added? 2 electrons to the product side. So this is the reduction half reaction because electrons needed. This is oxidation half reaction because electrons get removed. So these two are half reactions. To get the balanced chemical reaction, balanced ionic reaction, you need to multiply this by 2, this by 5. 2 times 5, 10 million. 2 times 8, 16 H pluses. Right? So here 2MnO4 minus plus 5 into C2O4 2 minus is 5. C2O4 2 minus plus the first we write the main two components, guys. Okay, because when we doing some calculations related with the redox, we should take the stoichiometric ratio of the initial main two components. That's why we write the main two components first. The other side too, then 16H pluses, then 2Mn2 plus, then CO2 gas plus 8H2O. 8H2O. Right, as the third one, take the reaction in between I minus and S2O3 2 minus. I2 and S2O3 2 minus. Third one. I2. Refer the chart. What happened to I2? What happened to S2O3 2 minus? Come on, guys, hurry up. Done. Shall we see? Right here, I2 8 plus goes to 2I minus. To get the same iodine, you need to multiply this by 2. Then balance charges. Here 0 charge, here minus 2 charge. To get the same number of charges, add 2 electrons. Gain in electrons, reduction of half reaction. Then S2O32 minus goes to S4O62 minus. Here 2 sulfur, here 4 sulfur. Therefore, to get the same number of sulfur, multiply this by 2. 2 into 2, 4. 2 into 3 is 6. To get the same number of charges, here minus 4, here minus 2. Therefore, add 2 here. Then how we get the final reaction? I mean, ionic reaction. Here 2 electrons, 2 electrons. No need to multiply. Just add reactants and product. I2 plus 2S2O32 minus, other side 2I minus plus S4O62 minus. This is the balanced reaction. Here 0 charge, 2 into minus 2 minus 4, other side minus 2 plus minus 2 minus 4. Right, okay Putala. So I'll stop now and we'll continue with the tomorrow at 8 p.m. and we will continue the balanced reaction in the acidic medium, redox balancing in acidic medium. So I think you could understand what I taught today. If you have any doubts, you can put a message, WhatsApp, or you can make a call. Right, so shall we meet tomorrow? Until that, take care.